Hi, my name is Jason Burns. You're watching the Astro Farmer channel. Today we're going to talk a little bit about the AVX and ways to improve upon your methods. If you're new to it, we're going to discuss how to set it up, easy ways to store it, and basic hand controller functions. This is going to be a beginner's tutorial about how to set it up and use it. All right, let's get started. So the first thing most people do is they've got a tripod sitting out, and you've read everywhere online that your tripod needs to be level, and they get real particular about getting it level. Well, that's not actually true. You're going to find out throughout this series of videos that there's going to be a lot of things that you read online that are just flat out false, regardless of the sources that you heard them from. It's good to have it somewhat level, but it doesn't have to be perfect. The main thing is that this peg right here does need to be pointing north. So there's a peg on top, as you can see, right here, and this peg needs to be pointed north. So once we've aligned this pretty roughly with north, and you can use a compass on your phone or an app, or you can use an actual physical compass, but magnetic north and true north is often, they can disagree a little bit. But for now, we're going to align it in a northerly direction. The second thing we're going to do is we have a tripod spreader. The tripod spreader comes with this doohickey, which is basically just a long threaded bolt. We're going to use this bolt piece, and it's going to thread up through the bottom. If we can get the camera in here, you can actually see it from the top as well too. And we're just going to thread it up some. Doesn't have to be threaded up all the way at this point. Just needs to be kind of threaded there to hold it in place for now. Next, we'll take our tripod spreader and our little finger nut here. We're just going to put it on like so. And we're going to go ahead and just kind of screw it on. But you'll notice I don't have everything real tight here. And there's no need for it just yet. The next step is going to be to install the actual mount head. Now, you'll notice when I pulled this out of my little deal here, and I highly recommend that you keep the foam that comes with your mount. Celestron sells a case that you can reuse that foam in, and it works better than my bubble wrap job. Now, this just sits on here, and you'll notice that these are loose. So when I show you the bottom of the mount, you can kind of see that there's a spot for that peg to go. Peg goes in the slot, and then we can reach back down here and take our central bolt and start threading it on. Why isn't that thread? There we go. All right. And then we'll come from the bottom and give it a little tension. And we don't want to bend and break this, but we don't want it moving either. And we don't want this muscle truck tight right now, but we also don't want it loose. At this point, you're going to polar align the telescope. You can go ahead and load your gear, or you can polar align it just like this. A lot of folks like to polar align right here. I don't. I like to put my gear on first and then polar align. More on that in a minute. At this point, we can begin by carefully moving the right ascension axis and locking the clutch so that we can install the counterweight shaft. And then we'll install the counterweight shaft, just threads in until it's completely seated. So one of the things about an AVX is you have to watch the counterweight shafts. You need to make sure that you don't just kind of snug it up and call it good. when you put this on, unlock this clutch. Now it can move, and give it some force. Make sure that you tighten this on good. Otherwise, if it works loose on you, you're going to start working on those threads, and I've seen that a time or two. It's not good. The other things you'll notice, for the most part, throughout this whole thing, I'm going to leave my clutches unlocked. The reason I do that is because there's nothing harder on a mount than moving this thing around, sitting here wailing on the gears. Inside of here, there's a motor with a set of gears, and then there's 2 gears on this side called spur gears, and then there's a worm that actually drives. And by moving this and banging this around, nothing good can come of it, okay? Let's go ahead and install a counterweight. And don't forget the toe saver. It's there for a reason. And again, I've got the clutches unlocked. So I always put my counterweight down a little further than I know it's needed, just in case I'm working up here with the scope and I don't have any bad collisions. The thing won't go and collide, okay? So always start off with your counterweight down a little lower than you think you might need it. And now we can put the scope in the saddle. Okay, as you can see, I got the scope mounted and I've got the counterweight down probably a little bit lower, but it's close. So what we do now is we check for balance. And as you can see, the counterweight wanted to come back just a little bit. When I let go of it, it kind of wants to come back just a little bit. Okay, I'm not sure the exact weight on here. It's probably around 15 pounds or so, maybe 14, something like that. All right, let's talk a little bit more about balancing. That seems to be where a lot of people get messed up. So what we mean by being east heavy is that, for me, east is that direction. West is this direction, and obviously I'm polar aligned to the north. So when I say east heavy, if I'm imaging in the sky towards the west, like you may be in the southwest, you may be pointing like this. You see how this falls to the west? See how that falls to the west? We don't want that. We actually want it a little east heavy. What that means is the telescope is going to be balanced in such a fashion where it wants to go east just a little bit. It wants to go east. It wants to be that side heavy, okay? Now, what if we flip the meridian? If I flip the meridian, let's say we're going to image, over here for a while, okay? Well, now it's the opposite, okay? I'm going to have to move this counterweight down just a shade in order for me to be east heavy. That was a little too far. See how it's falling? And this is a modded Avx, so it does move easy. But you'll get the hang of just using your finger. There we go. That's about right. So when you're looking at it and you know you're pointing north, just make sure that the east side is always going down a little bit further, okay? Same way with deck. In deck, you want to be tail heavy. That means focuser, backside of your telescope, you want to be heavy. It's okay. So how I do that is just adjust it with either the scope rings by sliding it in and out, or I slide it up and down on the dovetail. On a lot of scopes, you'll see me load a whole bunch of stuff up here, especially on the scope rings. I love using scope rings for stuff, and I'll actually load them kind of front heavy. That way it offsets all this stuff at the back. Counter to that, on some refractors, the objective's real heavy. You'll see me having all kinds of double finders for no good reason whatsoever, and having all kinds of weight back here, so I can slide this refractor up further and avoid peer collisions. Peer collisions are bad. Tripod hits hurt. That's why we never fully lock our clutches hard. Okay? I wanted to go over that balance with you guys because it seems to be really confusing for a lot of people. Just remember, whichever way you're going to point the telescope, it needs to be eastward heavy. So you have to decide on your targets which side of the meridian you're going to shoot on, because that's going to make a difference on how you balance your scope. You can try to balance it perfect. If you're on a pier, you can actually balance it where it'll work perfect on both sides. But there's a very fine line between making sure that those gears in the gearbox that I was talking about stay meshed. It's very important that they stay meshed at all times. As you can see, this scope's probably a little more than what most beginners would start off with, but that's okay. Honestly, this is just a 4-inch refractor. If I put a diagonal back here with an eyepiece, it would be no different than you doing visual with your 4-inch refractor or 80 millimeter or 6-inch refractor that you can buy with this mount. It makes no difference. So why not just load it up with everything, dew heaters and filter wheels and monochrome cameras and auto guiders, and we'll just start real simple and we'll work our way up. Okay, next I'm going to plug in the remainder of my gear, which involves the hand control and its mount. And you kind of got to decide where you want to put your hand control. I don't really have a preference. Some people do. It's just kind of a chintzy piece of plastic that's pretty hard to get on. I typically find myself facing south because the southerly view is just better. That's where all the fun targets are. So let's put it over here for now. And that just slips on. And this just slips in there. You can definitely tell it's a little dirty. It gets well used. Then the hand control can sit in there. And let's come up to these ports. The one that says hand control is the one we're going to plug into. Make sure it's fully seated and that it locks. You can actually plug it into aux 1 or aux 2, but don't ever plug it into the auto guider port, and don't try to jam it into the declination axis port. Speaking of the declination axis port, the very first gen AVXs had a different style of plug here. The reason why is because in the dark, you could actually plug stuff into the wrong place. And what that would do would insta-fry your mount. So make sure those are firmly connected. You'll notice they're a larger size jack. They have a different number of pins on them. Another accessory is the GPS accessory. It comes with a little strap, and you can strap it on anywhere. And you can also, if you have the GPS accessory, you can plug the hand control into the GPS accessory. And then plug the GPS accessory pretty much anywhere you want. Auxiliary 1, doesn't matter. But if you're like me, I don't really use the hand control that much. I'll just leave it plugged in there. And sometimes I just zip tie it down or zip tie it to a leg. We've got our scope loaded. This is a perfect time to polar align. By removing the cap on the front will give us access to this hole that runs through the right ascension axis. But it's not fully accessible until you rotate the declination axis 90 degrees. Until I rotate this, you don't have access to that hole. And now we have access to the hole. I have a polar scope, and I would recommend that you buy one if you don't. If you don't have a polar scope, it's fairly difficult to nail polar alignment without using some sort of software to help you out. Things like SharpCap or ASI Air or PhD2, Drift Align, several different flavors that you can choose from via software. However, if you're a visual user or you're just starting to learn to use the AVX or any equatorial mount for that matter, I highly recommend you learn how to do it manually. Here's the polar scope, and it just unscrews. And I always start by unscrewing the polar scope out first. I just unscrew it, and I want an open hole. So now I have access to an open hole that you can look through the axis and see literally all the way into outer space with no magnification. On the side with all the plugs is a meter in here that has numbers. There's a chart. Those numbers represent your latitude. So here, I just came from Nebraska. Right here, I'm at about 37 degrees, give or take. So I'll get it pretty close to there. Now, this is where, if your mount was not super level, when you first set your tripod, if your mount wasn't super level, that number can differ. So if you're on hilly ground and you need to accommodate and try to, you're just getting it close, but it's not quite level. If you're at 37 degrees, it may say 41, but the only reason that is because your tripod's not level. And as long as you understand that and still can put Polaris dead center through this hole, you're gonna be good, okay? After you've aligned Polaris using this and this to lock it, which I don't ever use this. A lot of people like to lock this. Watch what happens if I lock it on this gauge. I'm not sure you'll be able to see that. But anyway, if you're looking through the polar scope, it'll actually change. It'll actually knock it out of polar alignment. So this front screw here, I just leave it loose. I don't even use it. These two will give you access to the side-to-side movement that you need to get Polaris dead center of the open hole in the RA axis. After you've got Polaris dead center, then insert the polar scope. The polar scope threads in until it's fully seated. It's kind of long-winded. Inside, you'll see a diagram. Let me see if I can show you. There we go. Now, as you can see, it gives a diagram of where Cassiopeia should be. And I use an app. I get online and I use Polaris Finder or Polar Alignment Tool. There's several apps that you can download to let you know exactly where the small circle should be, whether it's at the 11 o'clock position or at the 9 o'clock position, because Polaris actually isn't dead center. It does move, it does rotate around the actual true North Pole. After I've dialed in polar alignment, figured out where it's supposed to be via the little circle within the larger circle, using these knobs and this knob, then we're ready for star alignment. We're actually ready to turn the mount on and align the telescope. For visual use, we'll use a 2-star alignment procedure. For astrophotography, we can use something a little more precise, from a all-star polar alignment to using plate solving. Let me put this back to its home position and we will continue on. Lining my index marks up, and now I'm locking my clutches. And I don't lock these clutches super hard. I don't want them to be so hard that if I have a pier strike or my camera telescope comes and hits my tripod, that it won't at least slip the clutch. So don't over tighten the clutches. Only tighten them down as much as the load needs. Okay? If you over tighten them real tight, you can actually bend the round piece of metal in there as a ring gear that sets on. You'll actually bend it and your mount won't track as good. You can actually kind of ruin your mount by getting all muscle truck with these clutches. So They don't have to be super tight. Now, after you've got your telescope polar aligned, you're balanced, you've got your scope on, your eyepiece is in, your diagonal, your camera, whatever you've got is all hooked up and ready to roll. Essentially, you're going to turn the mount on, and you're either going to do a 2-star alignment, a 3-star alignment, or you're going to put a pointing model in this telescope's mount. Okay, in the AVX's mount, you're going to create a pointing model that will give it an idea of where everything's at in the sky. And to go through that, it'll have you slew to a bright star, where you can select a bright star, and you'll have to get used to being able to identify bright stars from your location and actually put them in the eyepiece or put them in the center of the field of view of your camera and get them nailed down, at least 2 bright stars. So there is some learning there. A lot of times you're going to come back to that because you'll accidentally calibrate on the wrong star, and then your pointing model's off and you can't figure out why it won't go to M42 correctly. The other thing that needs to be done in the hand controller, one thing you'll have to do is make sure that you actually put in your time and location into the hand controller. You can also turn on the real-time clock, which means it'll keep those settings. Make sure that you get your longitude and latitude input correctly. Where there's a negative, there should be a negative and not a positive. The other way is you can just use its city's database and go like that. So if you're near Chicago, it'll have Chicago in there, and you'll input your time, and daylight savings time is another one that throws a lot of people off. Don't get mixed up if it's daylight savings time or not. Make sure all that information is correct before proceeding. Otherwise, your pointing model and everything can get a little goofy. And a lot of people struggle with that, but more often than not, it's either your time, location, your coordinates, or you've calibrated on the wrong star. So it does take some practice. For you visual users, there is absolutely nothing better than a star sense. And I know a lot of people don't like them. Most often, the star sense gets a bad rap for a couple of reasons. Let me pull it up here. One reason is because it may be slightly out of focus. You can actually focus this just a little bit. So when you're star aligning in auto and it comes up and says you've got not very many stars, even though it's a crystal clear night and there's tons of stars, check your focus. Once these are calibrated and set up right on a telescope for visual users, you're going to wish every single mount had came from one. People will actually go buy a Celestron mount just for this. They will switch over their Skywatcher mounts just for this, because you can buy it for a Skywatcher as well. Those are the same company. So we've got our time, date, location, daylight savings time. We've got that all input correctly. Double, triple check that. We've done at least a 2-star alignment. And now when we input coordinates from when we input say M42 or M16 to our hand controller, it's going to take and it's going to put it within the field of view of the telescope ideally. And that's pretty much it for visual use. From there, you can add things like Star Sense, which will automatically do the star alignment process for you. Makes it a lot easier. Star Sense is excellent for visual users because you can plop your mount down and throw your scope on, make sure it's pointed pretty much north. You don't have to be precisely polar aligned, and hit auto on Star Sense. And after you've done a single 1-star calibration with Star Sense, and assuming you haven't moved your Star Sense to another scope or done something weird, it will nail every target. Okay, so we've pretty well covered all the basics. Now that the basics are out of the way, we're going to cover some more advanced topics as you get into imaging and you decide that you want to take that leap and put a camera in the focuser. In the next segment, we're going to cover USB cables, back focus distance to focal reducers, when you should use USB 3 cables versus USB 2 cables, how far you can go, how far you should go, and a lot of other things. I'm going to go through the software, what software I use, and what software is free and that works really well with a laptop. There are other options such as ASI Air, Astroberry, and a few others, Linux options with indie drivers and things like that. But I'm going to keep it plain and simple. We're going to go with a simple Windows laptop, and we're going to make an AVX sync. I want to thank you for tuning into the Astro Farmer channel. The next series will be much more advanced. I hope you'll like and subscribe, and thanks for tuning in.